In this section, we will talk about the pressures determining filtration. Pressures, which determine the glomerular filtration rate, are: first is glomerular capillary pressure. Second is colloidal osmotic pressure in the glomerular. Third is hydrostatic pressure in the Bowman capsule. These pressures determine the glomerular filtration rate by either favoring or opposing the filtration. Let's make it easy for you. This is glomerulus. This is Bowman capsule. Glomerulus has blood. This blood has proteins. The blood, when past these glomerulus capillaries, filtrate will be reached to the Bowman capsule. This filtrate don't have plasma proteins. First is glomerular capillary pressure. Glomerular capillary pressure is the pressure exerted by the blood in glomerular capillaries. It is about 60 mm of mercury and varies between 45 and 70 mm of mercury. Glomerular capillary pressure is the highest capillary pressure in the body. This pressure favors glomerular filtration. Second is colloidal osmotic pressure. Colloidal osmotic pressure is the pressure exerted by plasma proteins in the glomeruli. The plasma proteins are not filtered through the glomerular capillaries and remain in the glomerular capillaries. These proteins develop the colloidal osmotic pressure, which is about 25 mm of mercury. It opposes glomerular filtration. Third is hydrostatic pressure in Bowman capsule. Hydrostatic pressure in Bowman capsule is the pressure exerted by the filtrate in Bowman capsule. It is also called as capsular pressure, as exerted by the filtrate in Bowman capsule. It is about 15 mm of mercury. It also opposes glomerular filtration. Now, using these pressures, are you able to find net filtration pressure? Net filtration pressure is the balance between pressure favoring filtration and pressures opposing filtration. It is otherwise known as effective filtration pressure or essential filtration pressure, as glomerular capillary pressure is 60 mm of mercury. Colloidal osmotic pressure is 25 mm of mercury, while hydrostatic pressure in Bowman capsule is 15 mm of mercury. So 25 plus 15 is 40, and 60 minus 40 is 20 mm of mercury. Net filtration pressure is about 20 mm of mercury, and it varies between 15 and 20 mm of mercury. Starling hypothesis and Starling force's determination of net filtration pressure is based on Starling hypothesis. Starling hypothesis states that the net filtration through capillary membrane is proportional to hydrostatic pressure difference across the membrane minus oncotic pressure difference. Hydrostatic pressure within the glomerular capillaries is the glomerular capillary pressure. All the pressures involved in determination of filtration are called Starling forces. Do you know what is filtration coefficient? Well, filtration coefficient is the glomerular filtration rate in terms of net filtration pressure. It is the glomerular filtration rate per millimeter of mercury of net filtration pressure. For example, glomerular filtration rate is 125 milliliter per minute, and net filtration pressure is 20 millimeter of mercury. So the filtration coefficient is 6.25 milliliter per minute per millimeter of mercury. This was all about this section. In our next section, we will talk about the factors regulating or affecting glomerular filtration rate, or GFR.